Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your paleo teacher, Jen, and it's time for Monday Musings. Therizinosaurs are some of the most fascinating dinosaurs out there. For a long time, scientists didn't know where to place them because their bodies were just so odd. In fact, when Therizinosaurus was first discovered in 1954, it was thought to be a turtle. Wild. In 1979, Segnosaurus was named and placed in its own family called Segnosauridae. It was separated from Deinocheirus and Therizinosaurus, which were also put into their own groups due to the fragmentary remains, i.e., their hands. Later that year, it was found that the pelvic features of Segnosaurids and Dromaeosaurids were so different from those of true theropods that scientists thought they should be put into their own infraorders. By 1982, Segnosaurus and Therizinosaurus were suggested to belong in the same group due to the similarities in their hands, excluding Deinocheirus, which we now know is an ornithomimid. In 1984, Gregory S. Paul concluded that Segnosaurs were not theropods at all, but were actually late-surviving prosauropods with adaptations similar to ornithischians. He based this on the morphology of the snout, mandible, hind feet, jugal, palate, pubis, and ankles. He even went on to suggest ornithischians were descended from prosauropods. Basically, Segnosaurs and other therizinosaurs are really just the monotremes of the dinosaur world. Weird stuff. In 1993, a new genus, Alaxosaurus, was named. It was the most complete large theropod from its time and place. While it was similar to prosauropods in some respects, the detailed morphology of both sets of limbs showed that the connection between Segnosaurus and Therizinosaurus was probably correct. Today, we know that they are, in fact, related and that they belong within Coelurosauria. Aside from Therizinosaurus and Segnosaurus, other notable genera include Nothronychus, found here in Utah, and Beipiaosaurus from China. So all therizinosaurs have long necks, wide torsos, and 4 toes on their feet, similar to early sauropodomorphs. Their hip bones point backwards and were partially fused, which is why they were first believed to be ornithischians. Of course, the most striking characteristic are the enormous scythe-like claws on the forelimbs. They had a much larger range of motion in the forelimbs compared to other theropods, which allowed them to reach forward further. Skin impressions from Beipiaosaurus indicate that therizinosaurs were also covered in a coat of primitive down-like feathers, similar to Compsognathid Sinosauropteryx, as well as some larger quill-like feathers that were likely used for display. CT scans published by Steven Lautenschlager and his crew in 2012 focused on the skull and brain cavity of Erlikosaurus, another therizinosaur, revealing it to have a large forebrain and suggesting it had well-developed senses of balance, hearing, and smell, all of which would have been useful in evading predators, finding food, or in performing complex social behavior. These senses were also well developed in earlier Coelurosaurs and other theropods, indicating that therizinosaurs may have inherited many of these features from their carnivorous ancestors and used them for their specialized dietary purposes. Eggs of therizinosaurs have also been found. The embryos in these eggs had extensively ossified bones, indicating they were precocial like ducklings, capable of moving around on their own. There was also a colonial nesting site discovered in Mongolia with at least 17 clutches. They were all in one stratigraphic layer, which indicates they only nested there once. Therizinosaur eggs belong to the eutaxa Dendrolithidae, meaning branching stone egg. They are spherically shaped, similar to hadrosaur eggs. They have rough surfaces, and they were arranged in a circular pattern. Well, thanks for coming to today's lesson, and make sure you tune in tomorrow for some fun therizinosaur trivia. Fossilize you later.